Problem is called combination sum 4. We are given an array of distinct integer called nums and the target integer target. We have to return the number of possible combinations that add up to the target. The test cases are generated so that the answer can fit in a 32-bit integer. Now the constraints are the following. For the input array, we have the length of 1 to 200, and all the elements inside of the input array are positive, so we don't even have a zero, so it's from 1 to 1000, and all of the elements of nums are unique. Now, this uniqueness enables us also to it's a hint that probably for a specific data structure that maps unique keys to a value. So that's something to think about. The first the first example we have 1, 2, 3. So basically those are our numbers, and the target is the 4. So we can either combine the 4 ones, and then 1, 1, and 2, 1, 2, 1, and so on. Basically, all of them, they are giving us the same target 4. So there are a total 7 combinations that we can have. In the second example, the nums are 9 and the target is 3, so we can only combine the units 9 elements, items 9 to get 3, which is not possible. We can either have 9 or 9 plus 9, which is 18, which is way larger than 3, so we'll just return 0 as the number of ways that we can get the target. Now, obviously, we had the combination sum 1 through 3, and they were like backtracking problems. But in this case, we will see that kind of the backtracking and the recursion are always connected to other major category of problems called the dynamic programming. So as we were explained in the coin change problem, if we have our items and we are trying to set them in a certain configuration to get to a target, the only important things to note is that is the 1, 1, 2 equal to 2, 2, 1, or is it not equal? That's the first thing. And also, can we reuse the same item multiple times? So is this permitted or it's not permitted? So in our case, this will lead to the loops, to the order of loops, item and target, and this will lead to the basically the order of each of the loop from which the order of the loop iteration. So basically, are we starting from the first item in the input array or the last, as we discussed in the coin change? So in our case, 1, 1, 2, and 2 to 1 are not the same. So basically, they are not the same, which means that our first loop now will go from 1 to the target. And then we can choose any of the items. So this will be our second loop. And because we can choose the item multiple times, it's just fine to go from 1 to the target, not to from the target to 1 in the backwards fashion, so we can roll back and not use the same item multiple times. So we basically have a unbounded knapsack here problem in the DP, and we'll just basically iterate over all of the targets. And for each target, we will be able to choose all of the numbers in the items. And now we only have to figure out the recurrence, the number of recurrence. So the number of ways that we can form a target is the number of ways that we have it right now, plus. So if we say that in a map we are keeping the number of ways that we can get the target I, which is ranging from 1 to target, then we also have to add the number of ways that we can get the target minus num. So I minus num for each of the items that we have, because for each we can choose any item here. So we'll be just adding to this key to value mapping. So for each target, we will be just adding to it the number of ways that we can fit different different nums. So for example, if we have 8 and we have items 2 and 3, then basically to get 8, we can either whatever we have right now, and then we can just check 8 minus 2 and 8 minus 3. So we'll check 6 and 5. The number of ways that we can get 6 and the number of ways that we can get 5 is the number of ways that we can get 8, because that's determined by the coins. It's not coins, but in this case, it's just numbers in the input array, the integers in the number in the input array. So using that, basically this solves the problem. We could also use DP array. Not a map, not a hash map, but in this case, it's just easier to retrieve the value. And we know that basically we'll just traverse through if we say that n is the input array length times s, which is the target, then we'll have n times s for the time complexity. And for the space complexity, we can just have at most s elements which are basically determined by the first for loop. So those are all the targets that we want to calculate as being the last target that we will return after the for loops are done, because that represents the number of ways that we can form the target s, which is just given to us by the as a parameter to the function. We'll start by declaring our map that will be basically just map the target that we are trying to find the number of ways we can build to the number of ways that we can build it. And for the cold start, basically just to start with the, as you know, as always in TP, we have the base case, we'll have the 0. So to get the target 0, there's only actually one way to get it, and that's not use any of the numbers inside of the nums. So it's basically an empty array is the subset that we are using. Then we'll iterate over 1 to the target inclusive, and the second loop will be the items that we have. Each time we'll be checking the interesting scenarios when the number is smaller or equal to I, so we can check if we can add up the number of ways that we can get I by checking how many ways there are to get I minus num. So that's what we do in the next line. We just check if we can update the map for the number of ways that we can get I by using the current number of ways that we can get plus the number of ways that we can get I minus num, because num is the value of the item that we are currently using. Once the for loops are done, we will basically have stored inside of the target the numbers of ways that we can get all of the combinations that yield target when summed up.